Okay, so we're talking about the SPDF models in the wave mechanical model of the atom. In the wave mechanical model of the atom, we share that electrons are located in regions of most probable location, which are called orbitals. We represent orbitals with little lines with arrows going up and down. In this diagram, it shows full arrows. I like to show half arrows because it shows that electrons are spinning as they're sharing the same space. And they would be spinning because otherwise you don't want two electrons in the same space. You are going to need also your old periodic table, and I'm just going to erase. I had some stuff here. Okay, there we go. You're going to need your old periodic table because that shows you the regions of the periodic table, like the S block here, the D block here. This is S block. And on the next page, we've got the P block here. Helium is S block. And then way down here, we have the F block, which we shouldn't get into. So the large periodic table should be helpful in order to help you remember the regions of the periodic table. Okay, so let's go back to this. Now I don't like how it says that. We're going to draw the orbital diagrams for the following. Chlorine has 17 electrons. So if you look at your periodic table, chlorine is here. Chlorine ends in this is the 1, 2, 3 P area. And when we're done, we can check ourselves. We should have whatever neon is plus 3s2, 3p5. That should be a way of checking ourselves. So let's make sure that works out. Okay, so we need to always start at the beginning, which is 1s. 1 orbital, 2 electrons. After the 1s comes the 2s, 3, 4. After the 2s comes the 2p. What you do need to remember is how many orbitals there are. There are 3 in the p. They fill one at a time, and then you go back through. That's called Hund's rule. It's because electrons don't want to share the same space unless they have to. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need to continue. 3s, 11, 12, 3p, 13, 14, 15, 16, 17. Now, the orbital diagram is complete. The electron configuration would be 1s2, 2s2, 2p6. These superscripts represent the number of electrons. 3s2, 3p5. Or what you could do as a time-saving measure is you could see the closest noble gas, which is group 18 element that you've already passed, which would be neon. Neon is 10 electrons. So this is all neon. So that's just substituting that. And then you add on 3s2, 3p5. So either one of these would be considered correct. Just to verify with you again, that was what it said. All right, let's keep going. All right, the next is nitrogen. Nitrogen has 7 electrons. You look at the periodic table. I'm not going to keep switching back. Nitrogen is in the 2p sublevel region. So 1s2, 2s2. You always begin the same way. 2p. Fill in all 3. 1, 2, 3, 4, 5, 6, 7. You could not double them up until they're all filled halfway. That's called Hund's rule. So that's our orbital diagram. 1s2, 2s2, 2p3. I suppose you could substitute in helium for this, but you know, that's not really a time-saving measure, so I'm just going to get rid of that. Okay. Aluminum has 13 electrons. Notice it's in the 3p sublevel region. 1s2, 2s2, 2p, 1, 2, 3, 4, 5, 6. So that gives us a total of 10. Now I'm at the 3s, 11, 12, 13. So you could write 1s2, 2s2, 2p6, 3s2, 3p1. Or, remember, you substitute the furthest or the last noble gas you've covered, which is all that, which is again neon. And then you just write 3s2, 3p1. Okay, our last one is oxygen, 8 electrons. It is in the second row. Okay, so we're going to do 1s2, 2s2, 2p, 1, 2, 3, 4, 5, 6, 7, 8, which is 1s2, 2s2, 2p4. Make sure that your superscripts add up to the number of electrons. If they don't, you made a mistake. Okay, so those are a little bit easier. Let's talk about here. This is a diagram that may or may not help you. It shows the filling order. So it says 1s, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d, and it goes on from there. Or what I like to do is just go to the periodic table and travel along. Remember, when we have the D sublevel region, there are 5 orbitals, and it is 1 energy level behind in terms of the number, the energy level number. So let's see how this goes. K has 19 electrons. I know it's in the 4s. I'm looking at my periodic table. 1s2. 2s2, and you're going to get in the habit. It's a little repetitive. You know, that's fine. So 1 at a time, Hund's rule. So that's 10. After 2p is the 3s. 11, 12, 3p. I'm running out of room. So 12, 13, 14, 15, 16, 17, 18, 19. So you could write all that out. 1s2, 2s2, and I guess I can. 1s2, 2s2, 2p6, 3s2, 3, that's a 2, p6, 4s1. Or what you could do is you could say the closest noble gas is all of this. All of that is argon. And then you're left with 4s1. You are absolutely welcome to do that. Vanadium has 23 electrons. So we know we have at least what we have for potassium. So again, getting repetitive, 1s2, 2s2. You can't abbreviate. When you're doing your orbital diagram, you can't abbreviate. So there's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. After the 4s, comes the 3D. Be careful. And I'm going to put it on the next line. Doesn't really matter. 3D. The 1 energy level behind of the D, even though it's on the fourth row, which is the 4th period, it's 1 energy level behind, so we call it the 3. 2, 3, 4, 5 orbitals in the D. So we had, let's see, 19, 20, 21, 22, 23. So again, you could write this whole thing out. Or what I'm going to do is I'm going to do the orbital, the noble gas configuration, which would be, just like before, argon, which takes you up to 18, 4s2, 3d3. Now, I do want to draw your attention to the periodic table here, because it will show you, come on, I don't know why it's not letting me, there we go. Notice that it put the 3D before the 4S. We know better. We know that the 4S comes before the 3D, so please be aware that it's slightly backwards. If you just copy it, I know that you're not thinking. I know that you're just copying it, so please make sure you're using your own brain. Cobalt is 27. Okay, here we go. 1s2, 2s2. 3, no, 2p. Oh my goodness, getting sloppy here. Don't be me. Okay, so that is 2, 4, 6, 8, 10. There's 10. After the 2p comes the 3s. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm going to go on the next line. 3d. 1, 2, 3, 4, 5. 20, 21, 22, 23, 24, 25, 26, 27. So You can do 1s2, all that stuff. Or just like before, we could say, okay, so cobalt, the noble gas that we filled is still just argon. So it's still just argon, Ar. And then we go in order, 4s2, 3d2, 4, 5, 6, 7. And make sure that adds up to 27, which it should. Zirconium, oh my gosh, zirconium is 40. Zirconium is in the 4D. Oh my gosh. Once we get here, let's take a break. Okay. Is there a way to copy paste? Well, I'll figure it out later. 1s2, 2. If you're going to draw it, I'll draw it. 2p6. Okay, so there's 10. Try not to get as messy as me. 3s2, 3p. Filling in one at a time, Hund's rule. And that is to argon. Then 4s2. And then after that comes the 3d. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, messy, messy. After the 3D comes the 4P. How do I know when to stop? Well, I know that it's in the 4D sublevel region, so I'm not there yet. 5S. And then after the 5S comes the 4D with 1, 2, 3, 4, 5. Now, zirconium is 2 in, so it's 2 here. So, now, the closest noble gas that we've already passed is krypton, which is 36. So 36 is all of this. Okay, so let's substitute that. I'll change the color to krypton. And then I have 5s2, 4d2. Okay. Good work, you guys. Good luck. I'm not going to make you ever go down into the F and do any of those, but you do need to recognize what those look like. Thank you.